Students, I welcome you all in my channel Physics classes. Today we are going to study internal resistance and terminal potential difference of a cell. First of all, let us know what is internal resistance. We know when current is passed through a conductor opposes the flow of current through it. In the same way, the electrolyte of the cell opposes the flow of current through the cell. So we can say the resistance offered by the electrolyte of the cell when current passes through the cell is called internal resistance of the cell. The resistance offered by the electrolyte of the cell when electric current flows through it is called internal resistance. Internal resistance is denoted by small r. Internal resistance is denoted by small r. And it has same unit as that of resistance, that is ohm, same dimension, everything is same. The internal resistance of a freshly prepared cell is very low. As the cell is used, its internal resistance increases more and more. So remember that internal resistance of a freshly prepared cell is small. Now the question is that what are the various factors on which internal resistance of a cell depends? What are the various factors? So students, the internal resistance of cell depends on nature of electrolyte, then nature of electrodes, number 3, distance between the electrodes, area of electrodes dipped in the electrolyte. In addition to these 4, there is one more factor, that is temperature. Internal resistance of a cell also depends on temperature. When we increase the temperature, internal resistance of the cell decreases. So keep in mind, internal resistance of a cell depends on nature of electrolyte, nature of electrodes, distance between the electrodes, area of the electrodes dipped inside the electrolyte, as well as temperature. Now, what is terminal potential difference? What is the terminal potential difference of a cell? When no current is drawn from the cell, the maximum potential difference across the terminals of a cell is called its EMF. Maximum potential difference. Suppose I take a cell and I connected both the terminals to a voltmeter. Then the reading of the voltmeter will give us what? EMF. But if a cell is in closed circuit, means current is flowing through the cell, then EMF of the cell will decrease, and the decreased value of EMF, student, is called terminal potential difference. Decreased value of EMF when current is drawn from the cell is called terminal potential difference. It is denoted by capital V. It is denoted by. So we consider a cell of EMF E internal resistance R is supplying current to an external resistance capital R. This is a circuit diagram. Pay attention. This is a cell of EMF T. Internal resistance small r is supplying current to an external resistance R. So that current in the circuit, students, is what? I. Keep in mind that external resistance and internal resistance of a cell are always in series. Since capital R and internal resistance is small r are in series, the net resistance of the circuit will be equal to what? R plus R. This is the net resistance of the circuit. According to also, my dear students, current is given by net EMF upon net resistance. So what is EMF? E, and net resistance is what? R plus small r. Therefore, we can say IR plus I small r is equal to capital E. This IR is the potential drop across this resistance, which is equal to terminal potential difference V. Remember that potential drop across external resistance R is equal to terminal potential difference of the cell. Therefore, we can replace IR by V. So V plus IR equal to E, that is EMF, or terminal potential difference is equal to E minus IR. This is the expression for terminal potential difference of a cell when cell is supplying current, or you can say terminal potential difference during discharge of the cell. From this equation, V is equal to IR, we can write I is equal to V upon R. So replace I by V upon R and solve it. When you will solve, you will find the expression for internal resistance is coming R equal to capital R E upon V minus 1. So dear students, this is the formula for what? Internal resistance. R is equal to capital R E upon V minus. That is the expression for internal resistance of a cell. We were studying till now when the cell is supplying current, or the problem was of discharging. Students, in our home, we have inverters. So when the power is off, supply is off, then inverter supplies us current. Means the energy stored inside the battery is consumed. But when power is on, then battery will be charged. Means energy will be stored in the battery. So during charging, we shall use the equation V is equal to E plus IR. So these are very important relations. V equal to E minus IR when a cell or battery is discharged, and when a battery is charged, then we use the equation V is equal to E plus IR.